So one of the things I'd like to discuss with you guys, since we missed one meeting, should we put one meeting at the end or just say, oh, okay? What's your guys' thoughts on that? Hello?
I'll be here in the summer.
So, well,
Just let it go.
just let it go, okay. So, you know, yeah, usually we go to May. And then, like, it would be a meeting in June, but probably June's hard because people are gone. So, you know, either that or we fit something in, it'd be pretty tough. You know, so, anyway. Sorry about that, but, you know, sometimes that happens. Okay, so a couple of things today. We have two presentations today. One from Joe and one from Charles. The other thing is, we received some merch for free. Woo! Yeah. So there's a company down in Southern Ontario called, what are they called?
Stockroom Supply.
Stockroom Supply, thank you.
Okay, yeah.
Do you guys, who knows Stockroom Supply?
Yep.
Great. Who buys from Stockroom Supply? Even better, because he sent me 2 gift certificates. Okay? They were $20, but hey, $20, $10 is $10, you know? So we'll have a little draw for that later, okay? He also sent up a couple of these things. So there's French curves and a couple of doodads for sizing wood. So, you know, whoever comes up first grabs them, they got them. The other thing is, if you don't manage to get one, probably between George and I, we can print them. Okay?
Are those printed or CNC?
CNC, not CNC, this was done on laser.
Oh, yeah.
Yeah. But, you know, hey, like this literally came out of the blue. I just opened up my mailbox and there it was. So Ethan's a really nice guy. He was telling me that his in-laws live in Brockville, so he's up in Brockville all the time. And we're going to try and get him to come up here and talk about the kind of stuff that he does. And they actually make tools.
Yeah.
They have a couple of tools that are kind of
Yeah,
interesting.
they make a drum sander.
They make a drum sander, but the other thing they make is an attachment to go onto your bandsaw for resawing on your bandsaw, which is really cool.
Yeah, it's cool.
Is it a
Yeah.
good one?
Yeah.
Because that's something I can
Cutting
I'm
for
looking
cutting
at.
Yeah, you end up with like perfect, you know, like none of them.
Even on my rigid?
Yeah, probably. Well, yeah, you know, I wouldn't go that far, but yeah. So anyway, and I talked to him about. He said they can retrofit them to pretty much anything.
Yeah.
So yeah. Anyway, so it's something I would actually like to talk to Brian, and see if they might start selling those here, because that'd be good for both.
Do you have a link to that?
Yeah, just go to Stockroom Supply.
Okay.
Look up Stockroom Supply.
Yeah.
And they are the only people in Canada who sell record power. So that's a British company, and I actually have a record power lathe.
Oh, that's right, yeah.
Yeah. So the record power, their MIDI lathe that I have is actually, they design it in England. It's manufactured in Taiwan or China or somewhere. Anything above that's actually manufactured in England. So it's a British company. It's not an American company. Just saying. Oh my God. Anyway.
Yeah.
Anyway, so I think what we'll do is we'll get started. So Joe is going to be talking to us about wooden hinges. I really want to learn how to do this.
Among other things.
Among other things, yeah.
So my name's Joe Federer, for those that don't know me yet. This is not my presentation. Full disclosure here, this is a friend of mine. His name is Garrett Burkhart. His name is in the bottom right-hand corner there. He lives in Fort Collins, Colorado. He was in LA for the longest time. He's an engineer. And if you know anything about your ethnic names, you'll know that he's German. And that's not why we met. We met because of the electric forums. When I first got my CNC, and Charles can attest to this, it's a learning curve that looks kind of like that and keeps going. Garrett was very, very helpful in my early days of getting me up to speed. He's very innovative, as you'll see in some of his stuff. And so much so that when he and his wife did a North America tour 4 years ago, with their RV. They parked in my driveway for about 3 days. So we got to know each other quite well. He was just at the time retiring his website, and he's developed a whole bunch of software for CNC type stuff. So I offered to host it, and George will send out the links and everything, and you can get his CNC software on my woodworking website. So without further ado, this is the presentation, but I'm going to take a bit of a detour first. And the detour is to show you some of the things that can be done.
Wow, that's,
Yeah, that's not it. But this is. Okay, so this is a box that he made, and it does actually have one of the hinges that I'll be talking about it. You'll see it in a moment. But it also features something else that I'll show you, and I have a practical example. And that is these, he calls them dovetail joints. They're CNC cut dovetail on the flat. Okay, now this is important. You can run a typical dovetail if you can mount your board vertically at the end of your CNC. But if you are limited to mounting it flat, well, he's figured out a way to do it. It doesn't look like your typical dovetail, but it looks like a dovetail. Now his has an additional complication of the opposite color inlay there. And
so that's just a dovetail cut within the dovetail?
Sort of. Not really.
Oh,
Okay, flipping over to the hinges for a moment. These are blanks for the barrels of the hinges, cut on the CNC. And we'll see the process for all of that in a moment. These are them stacked together. I'm jumping ahead in the slide presentation to give you a context of what the slides are going to tell you. So those are the barrels stacked up. That's it all glued together on the back of that same box. Now the reason for the plastic is obviously to keep things from binding and gluing themselves together where they shouldn't. Those are the fingers between the barrels, obviously. There's the finished box, and there you can see the hinge from the inside and from the outside.
Is that similar to the Rob Costman hinges?
I don't know. Now here's a little trick. So there's the big box, and there's a little box using the same approach. How big is that little box? It's not very big. There's my little, oh yeah, you can flip all the way to the other end. That's the little box. Okay, now how do you do it? Not like this. So he did this presentation, I believe, for the San Diego Woodworking Club 6 years ago. So there's his rationale. He likes things elegant. He's an engineer. He doesn't like to just use the easy approach. So there's that. I'll let you read that.
Can you put that up to slideshow? Takes full screen?
I don't think so because I'm running in Firefox.
No.
So obviously they've been around forever. Here's one from the 1800s, and in principle it can become invisible in the background, in the back of the box. Okay, so make short wooden hinge bushings or barrels from dowel rod or solid wood, as you saw in that photo. Groove to be routed on both sides of the box. Glue the bushings to the alternating sides. Insert a hinge pin, which I think he used just a brass rod. And it is invisible, but it doesn't move because it binds. So he goes into geometry. Now this guy, apart from being an engineer, he's amazing with visualizing three-dimensional geometry in his head. I think he does use CAD programs, but all of his design work is in here. And then he makes it real. So he would have visualized this, all the geometries, of what kind of clearances you need, what the angles are, what the dimensions are. And I haven't pre-authorized with Garrett getting permission to post this, but I'm sure he'll say yes, and if he does, when he does, then George will post this on the website, or in the email.
Sorry, I'm not quite clear on this. What we're saying here is that the pin through the dowels, if you move it slightly off-center, adjusts the opening angle?
That's my read on it.
Okay. How do you?
I haven't actually done this.
Okay. I'm just wondering, how do you, A, get the holes off-center, and how do you make sure they all line up as you're putting them in place?
Watch and learn.
Don't mean to rush or anything.
Okay, so the bushings can be sanded flush, especially because they are a little bit off-center. That makes it less likely you're going to have firewood. Works best with dark wood and inconspicuous wood grain because obviously it's not natively matching grain. Okay. All right. So here's really the meat of it, the important considerations. 100-degree opening angle is ideal for most boxes with hinge axis 1/8 dowel diameter distance from the outer box surface. And then, of course, allowances for different sizes of diameter dowels and so on. Less than 120-degree angle may make the lid fall shut, and you want it to be well past the burr. Greater than 120 degrees, and then there isn't a whole lot of material there. So it's a fine line between them. The groove must have the same radius as the bushings and be exactly one bushing radius deep. So accuracy, 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 gentlemen. If you're off, it ain't gonna work. Hinge pinholes must be exactly centered. Okay, when he says exactly, he means few thou. So get out your machinist's calipers.
So this is definitely a job for a CNC.
Not necessarily.
I'm trying to imagine how I would do this on a drill press.
They did it in 1900, I guess.
Also, it must be precisely perpendicular. Otherwise, again, you'll get binding, or you'll get your pin bending and eventually breaking. Okay, so here's his big disclaimer. I've been using a CNC machine to cut the grooves, cut out and drill the bushings. However, the grooves can be machined on a router table, and the bushing holes can be made using a precise lathe, metal lathe or pen making lathe, not your POS Sears that I have in my shop with run out that can be measured in millimeters rather than thousands. Note, the tailstock of my 24-inch swing wood lathe is not guided precisely enough to drill the holes, and he's got a good lathe.
Yeah. Yeah, no, I agree with, like, mine, there's no way I'd be able to get it that accurate.
I thought there was a tool I saw a video on this, and there was some sort of a tool that has a sheath, goes down over your dowel and guides your drill press straight through.
That's the Rob Cosman tool.
Is that the rock?
Yeah.
Ah, okay, I have seen that.
Yeah.
Okay, get a dowel rod with the right diameter, and again, accuracy is important. In a totally different context, I experienced this firsthand. I got some 1-inch dowel from Home Hardware, and then I got some 1-inch dowel from here, and I was making threaded rod. I think I brought in a sample last time of the clamp that I made. 1 inch is not 1 inch is not 1 inch when you buy it from Home Hardware. It is pretty close when you buy it from here. But in the end, what I ended up doing, I also started getting chip out when I used the Beal threading tool. So what I ended up doing at my neighbor's suggestion is I dipped it in epoxy and then I turned it on the lathe. That way the epoxy infused into the maple, that was maple I was using, and it stabilized just enough that I'm getting a lot less chip out. And doing it on a lathe, of course, allows me to do it exactly 1 inch. So when you put it into the Beal threading tool, it doesn't bind and it doesn't break anything like my first attempt did. Lee Valley is wonderful for replacing things that are a result of my stupidity. Okay, slight variance, length variance is okay, ends must be smooth and perpendicular. Accuracy. No, he mentions Harbor Freight, Princess Auto, are equivalent.
Oh, is that what that is? Gee.
Yeah, Harbor Freight is the American equivalent of Princess Auto.
Yeah, no, I'm looking at this machine, I'm trying to figure
What
out
is it?
what in the world
So-
is that?
Oh, it's a little tiny saw.
It's a really tiny chop saw. I've
Yeah,
never
it's
seen
probably
anything
about
like
that
that.
Wow.
That's what it looks like too, yeah.
Okay, and then he has some comments about sizes here. Drilling the hinge pins holes. Okay, holes must be precisely centered, coaxial, or the hinge may bind or look crooked, however slightly tapered is okay. Do not use a long jobber drill bit. And again, I haven't done this exact process, but I can vouch for that, because they sort of wave all over the place. Short carbide end mill works well if the bushings are longer finished with drill bit. I would not recommend using an end mill. They just don't start to cut clean unless they're very carefully guided, as in a CNC. But if you try to hand guide them, they'll hunt. So I would start it either with a brad point drill or a regular angle drill. Okay. Drilling technique on a drill press. Clamp bit upside down in the chuck. Don't over tighten. Lower drill chuck 1.5 inches and clamp bit shank in drill press vise. You must use a vise. Make sure there is no stress on the bit and hold down the vise in place. Open the drill chuck and return to upper position. Clamp the dowel pieces in the chuck and drill the hole. This is all to ensure the multi-step processes to ensure accuracy and alignment. Now, I don't know this for a fact because I have not visited Garrett, and in current political climate, I probably never will. But it looks like he's using something similar to my Taiwanese-made floor mount drill press. So as long as you follow his process, you should be okay, even with something that might have a little bit of.
How do you, I mean, I see how, like, it's a drill press vise, so the two jaws move in and out at the same time, so it stays centered. So I get that.
No.
It's like a
No,
pen,
the back-
it's like the vise they use for pen blanks.
Yeah, the back jaw isn't moving.
The back is fixed. Well, then,
No, you're doing manual alignment.
You're just trying to locate the
But you're only doing it once,
yeah,
because they're all the same.
yeah.
So you just.
So you make the same
triple
mistake each time.
You make sure you get it right the first time.
But they'll be accurate.
You'll be accurately wrong.
That's more firewood, it's okay.
Very small firework.
Yeah.
Okay, some practical aspects. We're talking these grooves, not these grooves. This, by the way, is done with another one of his pieces of software. So he's talking about these grooves here. Practice, practice, practice. Yehudi Menyon was once stopped on, this is apocryphal, I didn't see it myself, on the road, on the street in New York City, and was asked, how do you get to Carnegie Hall? He says, practice, practice, practice. Same thing here, practice with cheap wood. Grooves can be made on a router table with a core box or bull nose bit, same diameter as bushing. Measure your diameters, because they're not always consistent. Lee valleys are pretty good, but if you buy off Amazon or something, make sure you measure the actual diameter. I have had them out, I think I had a 1/2 inch that was like 0.493 or something like that. It was not 1/2 inch.
That's because quite often they're made in metric, and then they just put the,
Yeah.
you know, the inch equivalent for the American market.
Yeah.
So it's close enough.
Yeah, well, it's not. It's not, so measure.
Hmm.
Cut grooves 1/2 bushing diameter deep, but go incrementally and try with some bushings for a snug fit on both sides. If the groove is too small for the bushings, carefully widen and deepen the groove in the router table. Now, this is very much an incremental thing, and I haven't done this exact process, but I can tell you, if you try to hog off too much, it's going to be rough and it's just not going to work. and you'll have more firewood. Or a lot of sanding. In my case, it was a lot of sanding. Preparing for assembly. Now here he's got that plastic in there. Take the 1/8" brass pin and grind a sharp tip. Steel is an option, but of course, a lot less workable. Sand the pin smooth with fine grit paper. Cut 2" wide strip from thin polyethylene film, freezer bags. Thread the bushings onto the pin while alternating the film strip. And again, you saw a picture of that earlier on. And then assemble the whole thing. Mask everything off, apply glue sparingly. You don't want too much squeeze out, you don't want any squeeze out. Apply glue to the exposed halves. Tight bond works, but I prefer solid hybrid silane glue, Gorilla Clear glue. The box I'm going to pass around in a slightly different context. Garrett advised me to use Gorilla Clear. I'd never used it before. It's sticky, it's stringy, it's an ugly, horrible stuff to use, but it's got a long open time. So unless you want to switch to epoxy, I would suggest Gorilla Clear glue as an intermediate with a good long open time, and it sticks like, well, you know the expression, shit to a goose.
Yeah.
Seat the bushings pin well centered in the grooves, align the lid with the box, clamp down hard, and let cure. Now Gorilla Glue, it says 2-hour open time. I left my assembly, that box, for, I think it was at least a full day, it might have been 2 days, just to be sure that everything was set properly. Partly because of my ignorance, I'd never used Gorilla Glue before, at least not polyurethane. And partly because it doesn't set hard right away. It takes time to harden up. Even after a day, some of the squeeze up was a little bit rubbery. Where were we? Seat the bushings pin well centered in the grooves, align the lid with the box body, clamp down and secure. Remove the pin. Yeah. And again, from a different context, I know that it can be a real bitch to pull those pins out. So leave an extra bit of length, chuck it in the drill press, and on very low speed, just slowly back roll it. Remove the film strip, fill the remaining glue gaps, insert properly sized pin, and glue and end cap bushings, and obviously cut the pin to length. Final steps in the result.
Sorry, one quick question. Properly sized, you mean cut to length?
Yeah.
And then how do you keep it from
Oh, he
sliding?
mentions that, put in end caps.
Oh, so cut it shorter and then
Yeah.
glue in dowels or something in the end?
Or end cap with a sprig in it so that you can make it look like another section,
Mhm.
like a stepped dowel.
Yeah,
It's up to you. It's
Just a little pin, so it's like a
yeah,
horse and ten, and just,
yeah, it's aesthetic at that point.
yeah.
You just want to keep that brass pin from coming out.
yeah. Oh, actually.
Or you can probably ball peanut.
Yeah, I was thinking that, or I was thinking, what I did with the other chair I made was, I held the pin in place by tapping it and putting in a set screw at each end.
Oh, yeah.
So a nice brass set screw at each end would hold it in place.
Yeah, it's entirely aesthetic at that point. The point is that the pin shouldn't come out.
Yeah,
Although using your approach, you can get it out if you need to.
that too.
Okay, and then he mentions Rob's approach here, which I'm completely ignorant of.
Well, that's the Rob Costin program.
Okay, when he says in an afternoon, he means after he's done it a dozen times.
Yeah.
This is like those cookbooks, you know, the preparation time, 20 minutes. Yeah, right.
If it's really count.
Yeah.
May make the difference between an amateur project and a fine piece of wood, a piece of fine woodworking. Okay, well, that's all fine and good. So I'll just close that. And so, did you want to see the final pictures again, or shall I move on?
I'd like to see them again.
Okay. And I will-
I'm curious how the dowels attach to the box.
They're just glued in.
Pardon me?
They're just glued in.
So it's glued onto the surface?
Yep.
Yep.
Oh, so you,
Alternately though.
yeah,
Yeah, of course.
yeah, exactly.
So you take the dowel and you chop it up, is what you do, and then
Yeah, pretty much.
cut a piece of
And
it.
then thread it.
Not as sophisticated as I thought it was.
I mean, you could do those on a lathe, but what you'd have to do is, like, on a lathe like that, what you'd have to do is you have to put it in the chuck, drill halfway through, pull it out, turn it around, drill the other halfway through. Because it'll never come out exactly the center on the other end. And if it's out by a little bit in the middle, and if your hole's a tiny bit bigger, you're okay.
Yeah.
So that's probably the way to do that. And you'll get them dead center, at least on the ends.
On the ends, and as you say, the middle is a lot less.
Yeah, and if they're really short, like you're not going that far, and just use a really short drill bit.
And he did mention a couple thou.
Yeah.
And that's easily achieved using your approach.
Yeah.
What I've always liked doing is I've got a drill bit, like for 1/4 inch, which is 6 mil.
Mhm.
So I have a 6.5 drill bit,
Yeah,
and I find that works beautifully for things like this
Yeah.
when you're
Yeah.
trying to pass a pin in and everything else, because it gives you just enough slop,
yeah.
but not a whole bunch of.
But the other thing that's important if you're using a lathe is get a really short, stubby drill that's super sharp, and then just touch the end of it to make a dimple,
Yeah.
okay? You could even use just like a comb. You gotta have a dimple there, because if you don't, that drill bit's gonna wander all over the place.
It's called a center drill.
Yeah, exactly.
What I do, that's my version of that, is I use the live center to do that.
Yeah, you could do that,
I run in the live center.
yeah.
And then I was always wondering for the last several years why things weren't quite right. And then I actually measured the alignment of the live center to the chuck.
Yeah,
A little bit of adjustment and problem solved.
I have a pin that I put in the head and in the tailstock,
Mhm.
and it lines everything up, and then I just tighten, and I know it's dead on.
Yeah, that's basically what I ended
Yeah,
up doing.
but there's always a little bit of slop in the tailstock, right? There's always a tiny bit of slop in the tailstock.
Remember I mentioned I have a POS, old Sears drill lathe? Yeah, there's slop.
Yeah,
Yeah, you'll cut a taper versus a cylinder, and that's why machine lathes have lateral adjustments.
yeah,
And
yeah,
when you get rid of getting a cylinder, when you start getting a cylinder, you know you're on.
yeah.
Yeah, and that's exactly what I ended up doing. I used the lateral alignment. But even then, I had to eyeball it at the end, and then reverse my test piece, et cetera, et
Please
cetera.
try again.
Okay, I'm just going to quickly flip through the rest of these, so that was the final result there. Now, there's some other pictures I want to show you. All right. Here's some of the other work that,
Wow.
now this is it's actually connected to a video that I can't run because we're not internet connected here.
What a shame.
Yeah.
That's pretty cool.
You really need to see this video. You really need to see this video. This he did about 3-4 years ago, I think, and I've never seen the real thing, but I've watched the video many times. But he designed and built this whole thing.
What is it?
It is a clock. It is a clock. It is a marble clock. So you'll see the marble tracks there,
Oh, yeah.
there. And it's noisy. But what it does is it accumulates the marbles up here, because this section in here, this whole thing rotates. And it feeds the marbles from up here into the traces here, and they drop it into these time indicators here for the seconds, tens of seconds, minutes, tens of minutes, and hours. You have to see the video.
That is really cool.
What's
really
the
unfortunate.
title on the video?
It'll be in the link that.
We'll send you.
It's a YouTube video.
Yeah, he's working on a watch version now.
One thing that Garrett mentioned, and he posted this in the Vectric website when he got it working. It was a bitch on wheels to get working. Never mind accurate, just to get working smoothly, so it would do one full rotation. He was asked if there's going to be plans. He basically said, He used a rude word, I think.
So is the outer wheel, is it driven by a motor?
The outer wheel is stationary, the inner wheel rotates, and it is driven by an electric motor.
So it's just the accuracy of the motor measures the time.
Yeah,
And the dimension.
it's a stepper motor.
Okay, I've interrupted the video so that I can give you the information you need to visit some of the sites that Joe mentioned. The top line is the YouTube video that shows the workings of the clock. Now, this is not a clickable link. Instead, what you would need to do is pause this video, jot down that information, feed it into a browser, either the search field or the address field, and that'll get you to the YouTube video so that you can watch the clock working. The second line is a site where Burkhardt makes some comments about his clock, and you also see community reaction to watching the video. That second site also has a link to the video itself, so you get both with that middle line. The third line is a site that Joe maintains, and it has some of Burkhardt's software that you can download if you're interested. Now, today, as I'm editing the video, so February 9th, that site is not active. Joe expects it to be up and running in a matter of days, so you might have to visit a few times before you actually get access to the software. So, let me return you now to the main video.
Okay, this is what he calls the demon box. It's got the same hinge on the back. And this is a little locking mechanism. And he did it just for shits and giggles.
Is that like literally like a combination lock?
Yeah, that's the yeah, that's the combination lock. I have no idea how it works. But he calls it the demon box for many reasons. This is a CNC cut handle for something that you'll see in just a moment. He uses Vectric Aspire, which is the 3D version of Vectric. And it's actually 2.75D. It's not, you can't rotate and look at every angle. But it's optimized for CNC, which of course Charles will be talking about. And this is an example of what you can do with 3D CNC. It's all kinds of complex curves. This is brass. This is done on a CNC. Brass apparently cuts like very hard hardwood with a low feed rate, and sometimes you need to break down and use lubrication apparently. I've not tried it. I've tried aluminum.
Brass, you never use lube as far as I was taught.
Oh, okay.
But the problem with brass is it behaves like gum.
Yeah.
Yeah.
It will grab stuff. So what you have to do, and if you use a lot of brass, you should set aside a separate set of drills for the brass.
Mm.
And those drills, I was taught this by a German tool and die guy. You go in and you take each drill has two cutting edges, put a flat on each one, so that you're scraping up. Because when you pull the brass, bad things happen real fast.
Yeah.
So it's all about scraping as opposed to cutting into.
Okay.
And I've seen people get hurt.
I'm glad you have an expert, because I'm going from
that as well.
I'm going from knowledge passed on from my father, who tried to avoid brass. He worked in aluminum and steel, but he was a machinist. But he did caution me, as you just did, that brass is.
You know, it's so soft, it can't. And then they see it grabs the drill, it's spinning the thing around at high speed. It's like, okay.
That's what that brass and wood combination ended up looking like. Now, he's a woodworker and a machinist, and he decided to get into bladesmithing. He made that blade. He set up a forge, he set up a stamping press. This is all in his shop in Fort Collins. And he made that whole thing from scratch, from bulk steel.
Damascus steel?
He damascened it, yes. He folded it and hammered it and folded it and hammered it. This is his first attempt.
Don't you hate people like that?
Just, you know, they make it look easy. Oh, yeah, anybody can do this.
No, I made it more clear.
Yeah, it's supposed to be straight.
That's all.
Close enough.
Getting back to woodworking and CNC, he actually published this as a project for the Willing on the Vectric Forum. And, but look at the wall thickness on this. This is done in Vectric again, double-sided, three-dimensional. All done on CNC and then hand-fished. And it was just a piece of firewood. And I think that's it. Yeah, that's it. So yeah, there's the video that I can't run, but I do have something to pass around. Now, as I mentioned, Garrett does host his stuff on my website. And I have, I think, 4 pieces of software of his running on my website. And this is dovetail, thank you. I was having a senior moment there. That dovetail. I'll just pass that around and you can open it up. That was my second attempt at using this particular piece of software, just magnet. Just pop the top off, it's magnet.
Oh, it's magnet. Oh, nice. Oh, that's a great idea for magnets, when you bevel it.
Yeah.
Because I found, like, I've done magnet tops as well, and they're kind of tricky, because they got them to fit perfectly.
I'll just make a couple of comments on this. I didn't want to just flat, so I cut it on my saw-stop table saw at about a 30-degree angle. And then I had to close up the holes. And then I wanted to put a magnet closure on it, and I thought, okay, it's angled. How the hell do I get those magnets in there? So I took a drill manually and just drilled in on an angle. That mounted the magnets there, and then I said, okay, I have to plug those holes. I think it looks rather pretty. So, that's
How come you didn't drill them just a little hole and that's it?
alignment. I wanted to make sure the alignment.
Oh, the alignment was perfect, right, I see, okay.
Yeah, this way you're
You
guaranteed.
guaranteed you're dead on,
100%
okay.
alignment.
Okay, no, I got it.
So the joints there are done with his latest piece of software, and I meant to be,
These here?
yeah. So remember, this is done on the flat, okay? But what you end up doing is you find a very rare cutter, a ball cutter, that's got a 1-inch ball at the end, or smaller, but the key is that the shaft has to be substantially less. Because what you're doing is, and I really wish I brought the tool with me, but you've got your shaft and your ball, and you're relying on the ball to be greater diameter than the shaft so it can undercut.
Oh, okay.
So that's how those are done. And finding such a ball end cutter is challenging. I found exactly one from Yonico in New Jersey. They're only about $30. I mean, it's not that big a deal. Garrett managed to find some on Amazon US, which we don't have access to and probably never will again, that has a very thin shaft, like an 1/8-inch shaft, with up to a 1-inch ball cutter at the end.
That's scary.
No kidding. Scary isn't the word. Even with this, I've got a 2x3-foot CNC with all cast aluminum moving parts. I always stand behind the moving cast aluminum gantry, because if something's going to let loose, I've got a big chunk of aluminum between me and that tool that just let loose. And even then. Another piece of software that he has is to do finger joints on the CNC, again on the flat. This is an example of one of those that I ended up not using because something went wrong. And that's done with a 1/8-inch ball nose cutter. Okay, any comments or questions? Remember that I'm going to do my best to get permission to post all of this, the whole presentation, and definitely the link to the YouTube video for the clock.
Yeah,
Cool.
very cool.
Over to you.
Well,
Well, wait. Well done.
sorry, people. My intention was to come in here and show you some really, really cool stuff you could make with a CNC. You know, I was going to put together 3 or 4 different projects, a little bit of laser work, stuff like that, and, I haven't been in my shop in months, and I haven't made a thing. So this is going to be like, CNC in general kind of thing, how I came about getting into CNC and why, and what I went through and how I spec'd it, like literally what I was looking for in a CNC. And if you have any interest in getting into CNC or anything like that, you might find some of this interesting. And even if you're already in it or not, it's still pretty cool stuff, and I think it's worthwhile. The first thing is I wanted to get into CNC for quite a bit, but I was always intimidated by it. It seems like kind of complicated. I've been doing woodworking for, more than 50 years now, and anytime I've gotten into anything, I've always been able to figure out, like I know the machine. I've worked with it before, or someone's shown me, or I stood beside someone who used a tool and, just watched him and I went, okay, that's how you do it. But CNC is like a totally different thing. There's no just standing beside someone and going, oh, okay, press the button, and there it doesn't work like that at all. So it's pretty intimidating. But then I wound up doing, during that time when everything went shut down, I normally do whiskey tastings. Like I do a big show in Toronto, and I thought, oh, okay. And then everything shut down, and I had no show. So we decided to do it online, video tastings. And my wife proposed just taking a bunch of bottles, wrapping them up in bubble wrap and shipping them out like that. And I went, no, we have to make boxes. It has to be a nice presentation and everything else. So we started into it. I started making boxes and everything else. Our first series was 250 boxes. Our next series was another 250 boxes. And by the time I was up to like 1,500 boxes, I'm going, oh, this is nuts. This has got to be an easier way to do this, because I'm making them all, like in series. I'm stacking up sheets of plywood, cut to strips this wide and cutting edges into them, routing it and everything else. I'm like, there's got to be an easier way. So I started looking into CNC. I thought, oh, this is going to be so cool. All you do is just take it, put it in the CNC, program it, and if I want to make a bigger box or a smaller one, I just change the, everything, and there you go. When the pieces come out, and I assemble the box. Isn't that going to be great? And I didn't have a CNC, and I thought they were pretty pricey, so I went and had it priced. How much would it cost me to have someone else make it for me, like do all the cutting and just deliver the pieces to me, and I'll glue them all together? And it came to $6,000 some odd. And I'm like, oh man, that's nuts. That was for 500 boxes. And I was still like, that is nuts. That is not viable at all. So I started looking up online and everything else, and I'm like, man, you can get a machine for $6,000 of your own. So I thought, that's the way to go. I'm going to get myself a machine. So I started looking around at different ones and everything else. One of the first machines I looked at was this puppy. Actually, it was the original version of this one. This one's called the Maslow. Now, the Maslow is like, it's a kit. And you take a router, mount it onto this platform, and then it's got 4 ropes coming out of it, chains, whatever, and you anchor them down, and you can put it upright, or you can lay it down on the floor if you want. You can make it as big as you want, like 7 feet by 12 feet, whatever you want. It'll go as big or as small as you want. It's super neat. And then when you take it, you fold it all up, you just roll up all the wires, and it goes into a box about this big. It's like, wow, this is the ultimate shop thing. Unfortunately, and it's really cheap. So unfortunately though, it's also not very accurate. It's about like maybe 0.5 millimeter wave either way, which in CNC world is like, are you kidding me? And also it's good for cutting out big pieces, like on a 4x8 sheet. But if you're doing something small, like what you've got in your hand there, or whatever, or if you're trying to make something like this or a bunch of these, It's a bit of a pain.
It's
So,
impossible.
yeah, that too. So, let's try. So then there's this machine. Now, this one is the Shaper Origin. You've probably all heard of this one. This one is so cool. You put a bunch of tape down on whatever you're about to work on, and it reads it, tells you exactly where it is, and then you hang on to it and just and follow it along. This one makes the most sense from if you're a woodworker, tool user type person, you know, you put your hands on it, you're guiding it, the little screen there tells you if you're off or on or where to move it next and everything else. Deadly accurate. They have a complete library online of all this hardware, like thousands of pieces of hardware. So you've got a sauce hinge, those multi-layered hinges, and it'll, you know, you tell it what size, what model, what everything, and boop, it comes up on the machine. You just tell it, I want it there, and it goes and gives you a perfect, absolutely perfect read for that particular piece.
Never figured out how that actually does that, because you're manually moving, following a guide.
Neither.
Does the
I can
needle
comment.
Yeah.
kind of
Okay,
compensate
there are
it?
two little motors, and while you're moving the big movements, it's moving the micro movements within the bigger.
Makes sense.
Okay, I was always wondering about that myself.
As long as
Yeah.
you're in the ballpark,
Yeah.
it'll zero it.
Exactly.
So,
But you have to be in the ballpark.
Now, this is absolutely brilliant for the kind of woodworking, you know, like if you're doing something like this, for making joinery, for doing things that are standing up vertical, for doing like dovetails and the like. This is an awesome machine. And for installing hardware, doing inlays, things like that. However, if you want to do topography, 3D sculptures, laser work, anything like that, no. And if you want to work on a 4x8 sheet, if you feel like holding on to something, doing the whole thing on a 4x8 sheet, you're welcome to try it. Or to make 500 of these puppies holding on to that, don't. Okay, it just doesn't work like that. So, I mean, it's like, you know, there's benefits and disadvantages to all the different machines. Then there's this one, these next two machines, there's a variety of this kind of machine. This is like a gantry CNC. These ones, you're limited to like the width of the machine itself and the depth of the machine itself. So, like, you can't put a 4x8 inside that, obviously. This one's, I think, 30 inches by 30 inches, that model. They make a bigger one. This one's from CNC, a Canadian company, why I've got it up there. And these ones are, this is kind of like just about the most advanced hobby machine you can get. This, you can plug a laser into it. They've got a rotary attachment, so you can take something and do a complete 3D, like it'll turn, and as it turns, the CNC goes over it, and you can make little statuettes, chess pieces, you know, baseball bats, I don't know, whatever. So it's pretty neat. And they've got another option they've recently introduced where they have a vertical holding thing, so you can do things standing up on edge. So it's really quite the machine. And price-wise is probably one of the better values on the market right now.
I started with one of those, by the way.
Yeah.
And they're based in Waterloo, and great beginner's machine.
Yeah.
I'm glad I started.
Yeah.
How much are they?
At the time I got mine, which I still have, it was $800. They're about $3,000 now for something that's useful.
For the full size. Yeah.
Well, what's the company name?
CNC. It's like science-C.
SIENCI.
Yeah. It's like science, but with an I in the end instead of E.
Yeah, and
So
they're in
it's,
Waterloo,
yeah.
Ontario.
So it's science-y, CNC, yeah, anyway.
For sure.
And then there's this machine, oh, that's a great shot, wow. This is the Onefinity. This is also a Canadian company, and this is the machine I wound up getting. This one here, I I don't know why I wound up going with it really in the end. It was more expensive, but it just seemed more solidly built. Like this is a real tank, and it is super heavy. They advertise that it's portable. Each one of those components is about 150 pounds. Like the rail, that rail, and the upper rail are about 150 pounds each.
But that's
So-
how you get accuracy.
Oh, yeah, oh, no, it's awesome, utterly awesome. It's incredibly rigid and everything else. It's really quite easy to set up. The idea of portability is like, yeah, you could theoretically assemble the whole thing, say, on top of this table, and then use it on this table to carve into the table and do a three-dimensional, mountain scene or something like that. So it's, it's really quite interesting, but for what I was doing, I wanted to mount it in a permanent place, and just work around with it. So what I wound up doing was, here we go. In my shop is, I don't know, it's 340 square feet. I like the size of it, but that's pretty small, actually. Everything's on wheels in my shop, because to do anything, everything has to go over to this side, so I can use the jointer, then I have to move the jointer and everything else out of the way so I can get to the drill press, everything's like that. It's all on wheels, it all moves. In the center of my shop is my table saw with, you can just see the edge of it, my workbench. On the end of it is also my outfeed table, my assembly table, my tool storage, you name it. And the problem with this kind of machine is they take up a lot of space. Like, you think, I've got a machine, it's 32 by 32 inches. That's a workable size. I can probably find a space for that. But that's the work size. Then there's the outside of that, the rails, the motors hanging off of that. In front of it, you've got to have a dust clearance in the back, everything else. There was no way that I couldn't mount this on wheels. Even on wheels, I've got no place to put it to get it out of the way for my other stuff. So what I did was I've got this big doorway going into the other section of the garage that's not heated. So while most people don't bother with an enclosure on their machine, I had to. So I literally built an annex and put the machine into it. So I have the enclosure. And then the other thing is, it takes up a whole bunch of space on the wall. That's where I used to keep all my clamps. Like, they used to hang standing up. So that's why this is that's just part of my clamp collection, but still, I had to put them somewhere. The back of that cabinet on the other side can be removed, because invariably, whenever you put a clamp, there's something falls off or it gets shoved to the back, and so it's removable. Then there's all the drawers. 3/4 of this is made with stuff I had lying around. So those 5 drawers you see there, each one of them is a different kind of drawer slide. One of them is a push to open, the other one's a pull, but it closes by itself. The other one's, the top one's just your standard cheap kitchen drawer one. It's like, it's a variety pack. The cooler is because this is 4 feet. So sometimes I pull this out and stand on it so I can get into the machine, into the back and everything else. It's not so I can, keep my beer cold.
Although you can do that.
I could do that, yeah. So anyways, that was the whole purpose of this setup. Then what I did was I hooked up all the wires and everything else in here. These switches are, one's for an exhaust fan for when I'm running the laser. The other is for the vacuum that operates here to pull out the dust. This one is to power on or off the trimmer. And the other one is for this light up here. I keep a light going inside that box all the time because my shop is not heated. And this is a very delicate stuff and everything else, and you're not supposed to freeze it. So I keep a 90-watt incandescent bulb. You know, can you even find those anymore? Anyway, I've got a box full of them. So I keep that going all the time, and that helps keep it warm. So anyways, that's my setup. Up in the corner here, that is an aquarium pump. That's to blow air for my laser. So that, like, when the laser goes, it makes a bit of smoke and everything else, and that occludes some of the light from the laser going down. So this is just like a little bit of puff of air just to blow the smoke away and keep it away from the cut line. Let me see now. Anyways, my take on all of this, the way I put things together and everything else, the key word is kludge. Everybody know what kludge is?
It's my programming language.
Exactly. Yeah. You start with something that works. It might not be great, but it works. And then you go on to the next thing, and rather than get rid of this or improve and start from the scratch, you just build on top of that. So, and then you keep doing that. So, like, a lot of the stuff in my shop is really highly kludged. So, like stuff like, you know, the switches that I've got there, I had from some other project, I don't know. So, like, you know, and then, what do we got here? Okay, that's with everything lit up. Down here, this is I just wanted to, I wanted to get the controller out of the way, so I put it in a drawer underneath. And normally, supposedly, you're supposed to have it like right there beside the machine, but I didn't have space because I would have had to have made this cabinet still bigger, and I would have had less room for my clamps. So I decided, oh, heck with it, I'm going to put it underneath there. And then this back here, this is the back of the cabinet. I have a door there as well, so it can flip open. So what I can do is, even though I can't go wider than 32 inches, because that's the maximum width of my work area, I can do as long as I want. So I just made a door in the back, so I can put an 8-footer, and I can laser in the middle of it, or I can cut out pieces out of the middle of it, as long as it's less than 32 inches wide. Or I can do something 16 feet long and just, you know, work on it on the laser, and then using an operation called tiling, you move it forward 32 inches and block it off, cut out that, move it forward 32 inches, block it off, and go through the whole piece like that. So it's pretty nifty, I thought. And then there's my drawer with the controller out. One of the nice things about the Onefinity that is not similar to most other machines is most other machines, you need a computer to plug in. With the Onefinity, they have a controller box, so all I need is this same thing. I can download whatever I'm doing on this, and it just plugs into the back of the controller.
It's all G-code?
It's all G-code, yeah. And the big red button there is like, ooh, things are going messy, so you just stomp on it. I don't like to use it though, because then you've got to go reprogram everything and start from scratch, and it just takes entirely too long. So there's a just stop on the screen. So I always use that one.
Yeah, on the big red button, my machine has two of them, one on the main panel and one on the handheld. I don't recall ever using either of them, because as Charles says, if you do, you're starting everything from scratch. Reprogramming, resetting, realigning, almost everything. So you don't use it except if the house is about to burn down. And then you really use it.
Now, this here, the hose you see there is with any CNC. You'll often see people operating a CNC and there's no dust collection or anything like that. Ugh, it's like ugly, ugly, ugly. The dust gets in the way of the bit and everything else, and it makes things much less accurate and everything. But the other thing is, all this machinery is very, very delicate, and dust does not do it any favors at all. And particularly dust gets into any electronic components in that, it's really no good. So you really do need dust extraction. So what I've got is, this here is just something I kludged together with a bunch of things I had lying around. And this hinges so that it swings around, and this hose goes down into a cabinet underneath here where I've got my vacuum cleaner with a dust buster. Dust buster? No. What's the, dust deputy. Dust deputy. Little cyclone.
Yeah.
Right. So there's a cabinet underneath in the back of that, and this goes down into it, and then so it can swing around. So the idea is that no matter where the motor is, the hose follows it and extracts dust. And here it is hooked up to the rotor itself. This here, down here, is kind of like one of the big problems with a CNC is holding things in place. So you have a wasteboard, which is like, it's called a wasteboard because it gets wasted away as you work. You can even see some line marks and things like that from some other work I've done before. So the idea is with this one here, what I've got is 4 panels with holes in them for dog holes, and then the smaller holes underneath each one of them is a T-nut. So I can screw in hold down clamps. I can put dog, in the dog holes, I can put dogs in them, so I can clamp things to it and everything else. And then in between, underneath, are a bunch of T-rails, so I can also use them. So it's a pretty nifty little setup and everything else. And the advantage of this is the way everything's proportioned. Each one of any 4 of them can be taken and moved anywhere. Like they're all symmetrical, so they can all be moved one way or the other, and they can also be turned over. And then when they're worn out, I just toss them, make some more, because I've already got the program in the controller, and Bob's your uncle, I'm off to the races again.
So what is it, like 3/4 inch plywood?
It's just MDF.
Oh, MDF. Okay.
MDF is the cheapest,
Yeah.
it's like just,
Flattest.
cheapest, flattest,
Yeah.
stays that way. Now you can see the whole setup, the 4 of them, and underneath you can see the T-bars. And the way it's designed is these are intended to be sacrificial so they can get removed. But then I can remove them and work with the underneath if I want to use the T-bars themselves and the spacing of them. So I've got 5 T-bars. I want to modify this. I haven't done it yet, but I also want to put T-bars on the outside here and maybe one across the front.
So are the registration pins on that, Charles?
On the,
Because it has to know where 0 is, right? So.
oh,
Oh, okay.
yeah.
Okay.
That's where 0 is and everything else is automatically set.
Okay.
All I have to do is actually, on this one, you just go to the that little computer screen, press home, and it brings it up, brings it to the side, brings the Z up full height, done, homed. And then what I can do is just, I can, wait a minute, where is it? There we go. My joypad. But this is too much. This is actually, it's exactly what it looks like, okay? But it controls all the functions and everything else. So I can do it manually on this joypad. The 4 buttons here are 4 different speeds, so I can go woo, or I can go. This one determines which one of these operates which operation. The lights change depending on how it goes. This one's for Z, which is your up and down. And this one here is for your X and Y, which is this way and this way. So it's pretty nifty. Anyways, I can take that and I can move the trimmer to wherever I want it on it, and then I can press what's called home, and that tells the machine that that's where I'm going to be starting from now on.
Okay.
So from then on, whenever I go to do an operation or anything like that, no matter what the program is, the first thing it does is goes, and it goes to home. This is where I'll start. So it knows exactly where on the machine it is. Super cool.
If I can just throw in a comment there. One of the problems with home is that depending on the software, home is either in the middle, XY0, or it's in the lower left-hand corner. And you have to be absolutely certain you know which one it is for that run. Because otherwise you're going to have a crash bang.
Yeah, well,
Ask me how I know.
yeah, well.
Don't ask me.
Okay. And I don't think we need any of these. Here we go. This is the same machine, all set up with a laser. This is, speaking of crash bangs, you will notice a thin piece of, I don't even know what this stuff is called, but anyways, it's really, really dense and really, really hard. This is a repair patch on this because, as he just said, I went and programmed in everything and the whole bit. Let's go, okay, laser, home, and it went and baffed the entire, that holder is a magnetic holder that holds the laser aligned and everything, and it broke it, smashed it all to heck. So I'm like,
And I was there, and you've never seen two guys move so fast.
I thought I toasted the laser, that would have been, that's $750 down the drain. But anyways, it wound up, it was just that. Actually, it wound up being a favor to me because when I did all of this and everything else and fixed it up, I was messing with it, and it had a bit of play on it. And with a laser, you really don't want any play at all. So I fine-tuned everything, and actually this piece there held everything really nicely. So now it's actually better than it was before, and probably stronger too. The hose you see goes up and over to my little aquarium pump, so that helps blow things away. Anyways, I'm really looking forward to doing a bunch of laser stuff. I haven't really worked it out yet, but I'll get it. And then this is in the top of the cabinet. Originally, I had, once again, lying around for years, I had a 10-inch fan in a tube. It's meant for, like a household,
Like a bathroom
ventilation. Yeah, but for the big, ones. And I thought, oh, this is gonna be great. So I just made a box on top and I put that inside it, and then a 4-inch hose going all the way out to the outside through a window. And what would happen was I would, make smoke and everything else with the laser, turn the fan on, and it would draw all the air up, and it would hit the top of the box and come back down again. So you'd wind up with this, it looked like a donut, of smoke sitting there in the top of the box. None of it was going out. It was just, getting thicker and thicker donut smoke. So I went, so I just bit the bullet, went out, got a 2-speed bathroom fan, really nice one actually, Panasonic, believe it or not, and threw it in, and it works brilliantly now. So
What's the difference?
what's the difference? The difference is I'm not trying to take a 10-inch wide fan and bounce it and get it to go into a hole this big. Like what was happening was the air was coming up and hitting the top of the box and back down, instead of, I thought it would just, go through this smaller opening, but it wasn't. So now I just have, there's that, and the exit on it is a 4-inch So there's nothing to bounce off of or anything like that. It's intended to work with a 4-inch hose. And, oh, that's it. There we go. Okay. Anyways, that's my setup. That's what I wanted to do and everything else. The big thing that I wound up using it for, I don't know if you guys have seen this one yet or not.
There's no booze in there.
What's that?
There's no booze in there.
That's because we sold them all. Yeah, we did. Anyways, this here is the product. Partially, I'm finding most of the stuff I'm doing whenever I think, oh, I'm going to do something on the CNC. The first thing I do is I go, and how am I going to program it? And even as I'm thinking it, I go, I could just walk into the shop and just take my jigsaw and, and I'm done, or my drill and, But what I'm finding is there's some things the CNC does so brilliantly. It's just, you can't get around it. One of them is, like drilling flat-bottomed holes with edges and everything. And actually, I'm looking at this one, and this one was one I made with the drill. Ooh.
Don't tell them.
I've got about 30 of these boxes in my shop and everything else, and I meant to bring one in to demonstrate CNC. And here's one this is a demonstration one I made first. Oh, well, never mind. Okay. What I did find, though, was when I made these, I made 250 boxes, and the tops and bottoms were all made on CNC. And I was blown away by the level of accuracy that a CNC can do. I mean, I like to work to, high degrees of accuracy myself in everything I do. I'm generally like a 1/128th of an inch is my kind of, that's what I'm looking at and everything else. I don't like to leave much in the way of spacing or anything like that. A 1/16th of an inch either way is kind of, to me, that's really sloppy, right? And then I'm doing this, and I'm taking measurements as it's coming off the machine, and I'm getting 0.003, 0.003. 0.003 on every piece, 250 of them, and everyone is like to within 3 decimal points. It's like, that's wild. That's really wild. And the thing is, the way it does it, this is just a quickie thing. Do we have a? Oh yeah, we do. Okay. I thought this was pretty cool when I saw it, was you've got
Need a better pen.
oh yeah, no joke, eh? You've got a screw like that, and say the screw is there we go, and say each portion of the screw, each turn of it gives you 1/8 of an inch. So one full revolution gives you from here to here, advances 1/8 of an inch. Now what the CNC does, what the controller, what it does is it takes this and divides it up into any number. Like usually the number is 128, but I'm just going to go 32. Because, so try and imagine like one turn of this, one segment on this one is 1/16th of 1/8 of an inch advance, right? Like, is that a level of accuracy that you would like to attain? To me, that's just wow, So it's like to divide it up even more than that, 1/128th of an eighth of an inch. It's like it's scary.
How do you do a backlash on the machine?
How do I deal with backlash on the machine? It depends on the design of the machine itself. You know, there's different ones,
Well,
different
yeah,
things.
If you spend enough money and you get beautiful
Yeah.
round ball screws, you can make it.
Well, that's one of the, oh, sorry, I didn't even mention that, but that's one of the things I like about the 150 is it's got ball screws.
Okay, good.
Yeah.
Better than belts.
Yeah, yeah. So it's like, yeah, you don't really have much in the way of backlash in the first place. Even if it does go out of tightness and everything else, it's adjustable. You just, there's a couple of set screws and everything else, and, yeah.
Yeah, they tend to be preloaded bolt screws.
Yeah, I mean, that's the.
Hardly anybody uses belts on CNC anymore.
And that's where it gets, the more you spend, the better they get.
Yeah.
And that's why the price has gone up from $800 to $3,000.
Oh, wait, now, after 14 minutes ago,
Well, these are Canadian made with,
where do these components come from?
yeah.
Yeah,
Canadian made with Chinese.
Canadian mode with Chinese components. Unfortunately, if you go to the website, the prices are all quoted in US. Why? Because they ship from the States. Like they're made in Canada, but they ship from the States. So it's
Infinity
like,
does. CNC ships from Waterloo.
yeah. And actually, and that's one of the other things is, you know, when you start looking at CNC and everything else, you look at the prices. I mean, I looked at the price of the 150 I bought, and I was just looking, I found a piece of paper where I was doing all my estimates and everything else, and I'm there, oh man, I'm gonna do this. And it was $5,250. That was the whole converted to American, taxes, shipping, everything in, the full deal, you know, like with the laser and the whole bit. And I thought, oh yeah, that works. Yeah, but then I got it and I built it. I mean, you know, I had to get all the wood and everything else to build this. I had to get a vacuum cleaner for it. I had to get the hoses, the fan, these lights, the switches and everything else. And by the time I finally finished adding everything up, I was just short of $7,000. You know, and it's like, and it's never ending. I mean, there's tons of bits to get and everything, and it's like, oh, and don't forget the software, because software is like, if you look up online and everything else, they'll go, oh, there's all these softwares you can get that are free. They're free, and they're so easy. And maybe they are if you're computer literate, which I am not. So I tried 3 or 4 of them, and it was just, I had no idea what they were talking about right from the very go, you know? It's like download, no. Yeah, exactly. So I just bit the bullet and got Vetric, which is the same one, yeah. Although he's got the really expensive one. I've just got Pro, but
What's the price
yeah.
on Pro?
Sorry?
What's the price on Pro, if you don't mind me asking?
I don't know what it is now. Because I bought the desktop, which was 600 and something, and then upgraded to Pro, which
Okay.
was another 750.
Are there any like yearly fees on top of that too?
No,
Or is it
no,
just- it's just all-
no, it's one of the cool things about
Yeah, it's
Vetric
cool,
is
because-
you get it, you know, they upgrade it, but you have to pay for the upgrade.
Yeah, I see.
You know,
So-
but if you're perfectly happy with what you've got, you can go
Well, it
5,
doesn't
6,
get
7
super
years
buggy.
and still run the same stuff. I prefer that. Somehow or other, having software that you don't own, you're just renting it, just kind of, I don't know.
That's the business model now, though, man.
Yeah.
Like, that's all like that, mostly. Yeah.
I've been using Vectric software since the get-go, and I started off the desktop version, it was 450 or so at the time. And then I upgraded to Pro, which you just pay the increment.
Okay.
You don't pay a surcharge.
Okay.
And then I upgraded to Aspire, which is their 3D, which is not really 3D. And it's about $3,000.
Okay.
It's the big step.
Yeah.
And I'm on version 11.5, and I plan to stay there. Version 12 is out, but I don't want to pay the extra $600,
Fair
and I
enough.
don't need the new stuff. There are guys on the forums, there's one guy who's still running version 4,
Okay.
and he's
And it's
perfectly
still-
happy with that, and he's producing amazing results.
Nice.
You don't have to upgrade, but if you do, it's just the increment.
Yeah.
And there are no additional charges unless you want the laser module or unless you want to buy some of their pre-designed patterns and stuff.
Makes sense.
They're based in the UK, just outside Nottingham, I think, if I
Oh, yeah?
remember correctly.
Okay.
And they have not been acquired, they're an employee-owned company. The competitor is an online piece of software that's basically a monthly rental, which is why I didn't go with it.
Yeah.
Like Charles, I believe in
Yeah,
owning
yeah.
what I use.
I hear that.
Yeah, the other nice thing about Vectric is it's like from a woodworker's point of view, it makes sense.
Okay.
You can switch from inches to metric, you can go either one.
Right.
And you look at the programming and everything else, and it's not rocket science, it's not.
Yeah, it's intuitive for a woodworker, it's not
Yeah,
built by a programmer
yeah.
for a programmer.
And if you've ever worked with anything like Photoshop or
Yeah.
anything like that, it's like, it's a dawdle.
Okay.
Like from Photoshop to Vectric, it's like, oh, okay, yeah, you understand all the functions and everything else. I don't even have Photoshop, so for me, it's a bit more, but still, you know.
It's doable.
For me, one of the really big things is the forum. It is one of the most helpful, friendly forums that I've ever been a member
That's
of.
nice to hear, because it's important to have that
There's no
support for this kind of
negativity.
stuff.
On the internet?
On the internet.
I know, eh?
It's also heavily moderated. And the people are just nice.
Yeah, it's good.
And
Yeah.
it's mainly North American, but there's a lot of European presence there
Yeah,
as well.
that's a key.
Occasionally, you'll get a post in German or French,
Yeah,
and people will answer in German and French using Google Translate or
yeah,
whatever.
yeah.
It's very friendly
That's
and
nice.
very, very
Nice to hear.
helpful.
Cool.
Yeah. Anyways, sorry, this is like what I could come up with on short notice with very little time in my shop and everything else. I hope it's been informative and helpful. Anybody, any questions?
What's the minimal for the router power? Like how many HP that you?
Well, this one here uses a Makita trim router, which if you get one of these, buy yourself 2 or 3 of them because they're phasing them out, and they tend to burn out if they get used extensively. But yeah, a trim router is basically what this uses. You can upgrade to like a spindle. Yeah, but they're much more expensive, they use a lot more power. I can't, I would love to upgrade to a spindle, but my entire shop operates on one, like it's an extension cord coming out of my apartment and into my shop, and everything in the whole shop runs off of that one extension cord. So I can't do a VFD and all the rest of that, I just don't have enough power.
Yeah.
I mean, I can't even run my table saw and my vacuum cleaner at the same time, so.
Do you do
Yeah.
for dust collection?
On the table saw, I don't do a thing.
It's called a broom.
It's called a broom, yeah, that's pretty much it. I clean up after, yeah. But everything else is like, it operates.
How long did it take to build the box then?
How long did it,
Build the boxes?
to build these boxes?
Yeah.
Did that in a week and a half.
250.
For 250.
250 of them.
250 of them, yeah. Yep.
14 hours a week.
Yeah. Yeah, pretty much. No, about 9 hours, 9 to 10 hours a day, yeah. Yeah, it was a lot of work. Actually, I've got some photographs and everything else of that, it's like stacks of pieces like this, the entire length of my assembly table, and then, 250 boxes piled up in a wall as I'm building them and everything. Yeah, it's, one of the things I like about my shop is it's small enough that you can, or big enough that you can work on almost any size project, but you can only work on one project at a time. So I have about 4 or 5 projects that I have started, and then because I had something that had to get done and this only wanted to get done, it gets set to one side, and so they tend to get backed up. But actually that's one of them.
It's your,
Yeah.
nice. It's comfortable.
Yeah, that's my shop stool.
Cool.
Yeah.
Mike,
Yeah.
do you have a CNC in your shop?
No,
What you did?
not yet.
Oh.
That's what everyone cares about.
But after this presentation.
I already Googled it.
Okay, any other questions?
Let's take 5 minutes, just a health break or whatever, we'll come back.
Yeah.
The magazines frequently?
Yeah, there's free magazines over there. Anybody who uses
whatchamacallit shop here.
Yeah, stockroom?
Stockroom Supply.
Yeah.
I have a couple of gift certificates, and you guys can wrestle for them.
A glue up, and I thought, wait a minute, if I don't do the glue up, then I can bring all these little pieces and show you like, oh, we were joking up here. These are pieces, you buy these and you put your furniture. Just doesn't.
Super easy.
A number of years ago, actually, I made this, I do some of my stuff from plants, but generally from the fine woodworking. And I really like arts and crafts. And I really like a guy named Kevin Rodell who does he's in Maine. So I may never visit him again, I guess. Anyway, the last time our group had an event where we showed furniture was 2014, I think.
Wow.
And we were going to do our show in 2016 again, and we haven't done anything. So I made one for my son, and that was the one I did. I'll just pass that around. So that's a nice open view. And I'm going to be talking about this one, which is Kevin again, and a different one. So that's my son, and this one made for our new house. So almost there. With my friend Brad, who used to be a neighbor of mine, and helped move the shop. That was anyway, that's a whole other topic. So what I wanted to do is just put it together, show you without the glue how easy everything goes together and just fits.
That is amazing.
This is the first time we've done this. Oh yeah, first time.
We do have some epoxy here.
No, don't put that stuff away. Take that stuff away. You need something time.
Yeah.
It's okay.
We got a hammer, sorry.
So these legs, really simple to do.
Why do you say that?
Magic squares. I do a special laser that takes the squares right out. And let's see, 2, 1. See, everything by numbers. One thing about plans, that you spend half your time reaching a point with the plans, even with videos, and it just, like, wait a minute. So you spend another day or two correcting the mistakes you made. Anyway, this is see how easy it is?
But I didn't see it, that stuff takes some time.
You gotta pick it up, hammer it.
There we are.
That's true. Charles, you're in the shot.
So later on, maybe Monday night, Brad and I will be doing the glue up. And you reach this point in the glue up, and then you clamp the bottom. So it holds everything in tight there, and then you glue these on. And then you have to do some kind of quick stuff, but these are 2 corbels, A and B. Makes it easy. So I'll show it here. So these are part of this structure. And what you do is you do a little bit of shaving in here. You end up at an angle like that. And then that goes home. So this is going to go all the way down to here. So then there's 2 of these, one on each side.
How do you control, sorry, but how do you control the depth of it?
don't go too far.
You're adjusting the thickness of it so it rests.
Yeah, this, no, it's not gonna rest, it's gonna go right through.
Yeah, no, it'll go right through, but I mean, you're
You have to do
but you're
some
adjusting
calculating.
how far it goes in.
Yes.
By how thick this is, and.
Yeah, part of it is taking that out. So
Just
that,
wedging it, right?
yeah, you're wedging it. So
Yeah,
it's basically,
Till the top is flush
it's a
with the
mortise.
table.
If you want to take a look, you can see this is a mortise,
Mm-hmm.
and this is a tenon,
Yeah,
and what you do is that was the hard part.
yeah,
Because at one point I had to redo the thickness on this, like, so I had to do another one. Because you have to be really careful getting it right.
yeah.
Well, you've never driven those home before, have you?
No, that
It hasn't been adjusted yet.
because the interesting thing is, this is where your 1/28 things come in.
Yeah,
I was about to do that, and I was just gonna go, I have when you do a pattern, anyway, template, thank you. And and I have where I can do that.
yeah,
So if you do that ahead of time, when you're gluing, and you're committed to the glue up with these in, this would be totally screwed up.
yeah,
If you get in and don't do it right,
yeah,
so you have to do that after the glue up, so the glue is drying, and then you shape that.
yeah. So this is going to wind up, it'll be glued in
And
place.
you try, this will end up being moved into here,
Okay.
it'll be down here wedging,
Hmm.
and then you'll clamp these. When all of that is dry, and these are in,
You drive them home before the other glue is dry.
yeah,
Yes.
You
then,
have to, yeah.
this is completely finished.
Yeah.
So then you turn it over and you muck about and you've got the whole thing.
Did you fume that? Or did you
No,
finish it? You
no, I don't like,
You don't like the
I
fuming?
don't like the fuming.
Okay.
I like the wood to show, and you can,
Yeah.
and, so this is basically gives you an idea
Mhm.
with the finish, simple finish,
What is the finish?
it's,
Tongue oil.
green wax,
Okay.
tongue oil. And I use that on everything now, because you can rub it on, the more you put on, the shinier it gets.
Yeah,
So you kind of have all that together. But anyway, that's
How are you gonna connect that?
this.
Yeah.
You'll have to show you underneath.
screws?
Screws. There's an interesting example of when you make a little error and you do the countersink here too.
Yeah. Putting screws underneath, are you not concerned about expansion and contraction?
No, this will just,
Or are you gonna oversize the holes?
they're slightly oversized here. They go into here.
Yeah,
So there's a whole art form of getting that right.
yeah,
Don't need to worry about that on this. This isn't moving. The stretchers.
no, that's not something that's added, worry about the tabletop.
That is,
That's
Not
it.
move that much.
that isn't,
There's enough to be in there.
Especially if it's 8 points in here. Yeah.
it won't meet that.
It's a beautiful piece.
It is a beautiful piece, yeah.
That is a beautiful.
Isn't that nice?
It's really nice.
So instead of the corbels in here, just, he's got some great designs.
Yeah, this is a limbered design?
Yeah,
Yeah, I like this stuff.
Wayne, do you actually need to glue the Corvettes in place?
the corbels, yeah.
Why? If you're driving them home.
No, but that's just the bottom.
Yeah, they'll pivot.
So that'll be clamped in.
Yeah, so it's just gonna look like a tusk tenon.
Yeah,
Yeah, like it could.
So when it's all done, you'll be able to see down below here, it'll come
Yeah.
just above where that is.
Yeah,
But boy, is it ever, it's an interesting thing because you always have to be thinking about, well, how thick is that going to be, that tenon,
Mhm.
when ultimately I come to the very end
Yeah,
and in there?
yeah.
And of course, when I was doing the quick sanding, I spent a hell of a lot of time.
Yeah.
I don't know whether Brad talking about the entertainment universe, right?
Mhm.
Which we all are.
Yeah.
But I redid the board.
Mhm.
I haven't done all this. But, and then I had to make sure I was treating it like it's a tenon
Yeah.
and this is a mortise, you idiot, right? Like but this is when you're following plans
Yeah.
or you're just doing all the cutting. So think how long ago I did that.
Yeah.
And then you come to this. So I was too narrow at one point.
My problem with plans is every time I come to a plan, I start looking at it and I go, that's not how I would do it.
Yeah.
You know, so it winds up getting totally changed. It winds up looking like the plans, but
Yeah.
it's not built the same way they
No,
do.
it's really hard. And so it's fun too, like there's little defects here, but also getting these patterns with two boards that you're not mirroring and stuff. So that was kind of fun. Quarter-sawn white oak, for those who don't know.
Yeah. No, you can tell from the Rayflex.
Yeah, and when it's all done and it has that nice look,
Mhm.
that's what I prefer than the smoke.
Okay.
thing.
Yeah.
It's just so dark.
When you fume it, yeah. I've never done it myself, actually, but, yeah.
You've never driven the Corvette solo, which I understand why you wouldn't.
Yeah,
do
yeah.
it. So there's always a very small risk that you didn't quite get the tendons right, and they're not gonna drive home as far as you want them to.
Yeah, well, it'll get there. Before I start the glue up, I'm gonna shave a little bit off, because it doesn't take much like that. You're over and, let's make some more of these.
All the shim.
So, yeah, it's kind of fun. Doing the patterns is an interesting thing. Anyway.
It's a beautiful piece of work. Really nice.
With a CNC. So it's interesting seeing your two presentations and then, okay, this is the conventional stuff.
Yep.
You're using a tunnel finish on the bottom?
Yeah, that'll all get.
It's awfully finicky doing all those squares.
It's, well, yes, well, as Brad can attest, he's been able to watch and listen. Listening is usually lots of swear words and goddams and things like that. But anyway.
You can do better than that.
Yeah. But that's the whole, putting this shelf together, and then you get everything just perfect, and then if you oversand or overplane, or you just toast, right? Like, so you really have to keep trying, keep fixing, keep watching what you're doing on the next step. Anyway, it's kind of funny, it's like a little paint by numbers, so if you like that, it was worthwhile waiting a few days for the glue up.
Yeah. Beautiful. No, it's gorgeous.
Okay.
Just design-wise, I much prefer Limber to Gustav Stickley, but
So you're gonna bring this in next month to show how it
Well, we could, we'll see. Take a picture, we'll take pictures of this. Anyway.
Thank you.
Good?
Yeah, so this is fun. So I had a project. So first year high school exams, right, final week, so those went well. And for shop class, we had to make a speaker, an ambient speaker. So basically the way they work is that it is a chamber and the sound is amplified without electricity. And the assignment was make a speaker that either makes it sound better or amplifies the sound. So I made one here, and this makes it like music sound better. Specifically designed for my phone because that's the sizing. And here's how it works. So it mildly works, but it works just well enough. It's less tangy, basically. The sound, like it sort of works. Instead of stuff sounding like it's in a tin can, it sounds, more normal, I guess you could say. So yeah, I made this 3 coats of varnish, sanded it a bit. The way I made it was I laminated first 2 boards together. Then you cut out the inside on a bandsaw. Then took the next 2 pieces that I had, put those on top. I used a scroll saw to cut out this part here.
Nice.
Yeah, so went pretty well. I got a 87% on it. So
Very nice.
yeah.
There you go.
Excellent.
Well done.
Very good.
Plan to be this far back, but anyways, I don't know how much woodworking there is involved in this. I mean, I made the base, so that counts. And these little, I went to Preston Hardware, and I was looking for little, I think, what are they called for lamps? Finials? Yeah, right. And I was looking for finials, but with a 1/4 inch nut on the inside. And I couldn't find any, none. So I had to get these just plain ordinary drawer knobs and take them and drill them out and put a 1/4 inch, 1/20 nut on the inside with epoxy, and then finish them off with my favorite finish, Levos. So anyways, and then the rest of this is all Japanese shoji paper. It's standard paper, but it's got like filaments of like a shiny kind of plastic, really thin Tyvek type material. And then the center of it, there's a clear plexiglass 6-inch diameter tube, goes from here all the way down to the bottom. And then inside that is a 2 1/4 inch white, some kind of plastic, ABS or something like that, tube, and it's lined with
Nice. Cool.
lined with LEDs. So it's an LED tape going spiraled all the way up, and it's adjustable to different levels.
That's really cool.
And then it also does special effects, but I hate getting into them because I can't get out of them. But it'll blink on and off to patterns and stuff like that. Why someone would want a lamp that blinks to patterns, I have no idea. But anyways, that is my presentation. How did I shape?
Yeah.
Well, actually, the way I did it was I stacked square pieces of 3/4 inch ply, the same size as this. Cut these on a paper cutter to approximately like within a 1/2 inch of the size. Stacked them all, clamped them, and then drilled through the ply and the paper all the way down, all in one pass. The total package was about this thick.
How did you shape the paper?
Oh, shape it? That's just the shape of the paper.
So it comes.
It just curls and
It's lovely.
yeah, it doesn't lay flat. It just just kind of does all this. What I did was every piece, every second piece, I would rotate so that it's like so I don't get the same edge or whatever all the way down. Although if you look, you still get a bit of that, but
Is that rice paper?
No, it's just standard like real paper, but it's got like thin sheets, thin strips like threads of Tyvek, so it's kind of shiny and fancy and stronger than regular paper.
Where do you find it?
This got at the Japanese paper place in Toronto. I've had this sitting around in my shop. I used to make shoji screens, so I've had this sitting around in my shop for that long.
About that long.
Yeah.
Is there any separation between them, or are they just stacked on?
Yeah, in between each one of them is a 3/8 of an inch, 1/2 inch diameter. They're white ABS standoff. They're used for, I get them from a place here. They're used to hold electronic boards
Oh,
off
yeah, yeah,
of the back.
Yeah.
So, yeah, you just buy them in a bag of 1,000 and just use 750 of them. And then the core of each one of these is cut off 6-foot, 1/4-20 steel rods. So, I actually wanted to build this up to the full height and everything else, but I ran out of paper, so. It was like literally, every single sheet I cut went into this, and I took it and just hit the calculator, started computing, and okay, right there, and there you go.
Yeah, there's
Yeah. Does anybody else use stockroom supply?
We still got one, eh? Okay. I'm the new guy, though. I don't want to take free stuff on the first day.